Okay, well thank you very much for the kind offer to come and speak today. I'm Phil Reeves, I'm Vice President of Consulting at a firm called Stratasys. For those of you not familiar with Stratasys, we are the world's largest 3D printing company. We're about an $800 million company making 3D printers, running factories with 3D printers, making software that drives the 3D printing economy. I run our consulting division, working with large corporates around the world, helping them put 3D printing into the value stream. For those of you not familiar with what 3D printing is, let me just give you a very quick 101. Ostensibly, 3D printers are just CNC machines. They work in a slightly different way to a traditional CNC machine in that they consolidate material together rather than removing it from a solid billet of material. So really 3D printers are driven by two things. One is a raw material feed and one is digital data. Because whatever digital data we feed into a 3D printer produces the object that comes out of it. Hence the reason we call it 3D printing. We also call it additive manufacturing. And it's not a new concept. It's actually been around for 33 years. So it's actually become quite well established in a number of companies. There's actually 7 different types of 3D printers. So if you've seen it on the Big Bang Theory or if you've seen it on the TV, you've probably seen one type of 3D printer. There are lots and lots of different types. What that's manifested over the last 33 years is the ability to print lots and lots of different materials. So you probably think that 3D printers just squeeze out hot plastic. Yes, they do. They squeeze out ABS, and for the non-engineers, I apologize. They also squeeze out things like polycarbonate and nylon and carbon composite loaded nylon. We also 3D print in metal. We print in titanium, Inconel, Hastelloy, Waspaloy, tool steel. We print in ceramics, high temperature resistant materials, wear resistant materials. So 3D printing has matured significantly over the last 30 years to a technology that is a very stable way of producing tangible products. So how are people using it? Well, what we're finding in our company is people are using this technology to drive up the top line, bringing new products to market, things that couldn't be brought to market before in lower volumes, or they're using it to drive up the bottom line, productivity improvement, putting it on the shop floor, getting it to drive out some of the waste and inefficiencies within the business. So let me give you a few ideas of where it's being used. 3D printing is still used for prototyping. That's how we started our industry, making form, fit, function, visualization prototypes. Whatever you can design on a computer, you can print as a tangible object. And you'd think VR was going to replace that, but trust me, it isn't. It's having no impact whatsoever. More interestingly though, 3D printing is finding its way onto the shop floor. Jigs, fixtures, tooling, robot end effectors, fixtures for coordinate measuring machines, go gauges, no-go gauges, tooling, drill guides, positioning guides, all being 3D printed because it's more cost effective than machining. And we're now seeing a lot of tooling being made by 3D printing. Composite tools, blow molding tools, sacrificial layup tools for composites, even composite layup tools. So over on the Stratasys stand over there's some examples of all of this. The big thing that we're really pushing now is printing products, directly from digital data to end-use component part. And there's a lot of reasons for doing that. Obviously, this is a digital process, so we can make very low unit volumes in very cost effectively. We can also design things that you can't make using traditional manufacturing approaches. So it's a good way of bringing very complex parts to market. So that's a background on 3D printing. That's your 101. And my job was to give you 7 tips on how 3D printing can help you. So I think tip number 1, just consider industrial 3D printing is a lot more than just printing shapes. It's a tool set that allows you to make truly functional prototypes. Parts that you can use under a vehicle bonnet if you want to test your engine. Parts you can put onto a fuselage of an aircraft and do pre-production testing. So prototyping has been pushed forward with 3D printing quite significantly. In terms of your business, other ways of thinking about 3D printing is how you apply it within the business on the shop floor. If you're in a production engineering environment, or if you're in a process industry, petrochemical, pharmaceutical, oil and gas, food, how much production loss time do you have because you don't have spare parts on your line? Think of 3D printing as a potential way of getting spare part inventory in a production environment, digitizing the inventory. And what you'll see is the suppliers of your machines are already starting to use 3D printing in some of the component parts. We're seeing the same thing with shop floor jigs, shop floor fixtures, as I said, end effectors for robots. Lots of reasons for making components on the shop floor by 3D printing rather than machining them from solid. If if you're in an industry that uses tooling, if you're in the low volume manufacturing industry, but you're spending a lot of money making tooling for composite layups or for blow moldings, vacuum forming, again, think about the idea of 3D printing the tools. Not the end product, let's print the tool. Very, very rapid way of going from digital data to having a tool that you can put onto the production line. Significant way of driving down costs, but more importantly, it's a lead time reduction. So to give you an idea, let's say a large composite layup tool, something 3 foot by 3 foot, we can print in probably 36 to 40 hours. Now you compare that to getting that thing machined, big difference. Other companies, if you're in an industry that touches consumers or touches patients, if you're in the medical sector, in the bio sector, think about personalization. Is there a top-line growth opportunity to bring products to market that are new and innovative, that are personalized to individual patients or customers? You've not been able to do that before because you've been constrained by traditional manufacturing, jigs, fixtures, tooling, capital investment at the front. Well, if we have no capital investment anymore in injection mold tools, then we can print individualized parts, unit volumes of one. So we're seeing a lot of this concept of personalization, digital data from the customer, digital supply chain, 3D printed digital manufacture, and bringing individualized products to individual customers, patients, consumers. Maybe you're a different type of company. Maybe you're a company that carries a lot of spare parts, a lot of capital inventory tied up there somewhere around the world, sitting on shelves. Maybe 3D printing is a way of reducing all of that capital investment. Maybe it's a way of printing parts to order as and when they're needed, where they're needed. So a slightly different approach. So I guess finally, as a final tip, if you want to maximize 3D printing, look beyond just prototyping. Look into the factory, look across the assembly line, look across the supply chain, look in your inventory in your stores, look at your customers. I'm sure you'll find many opportunities. If you can't find them yourselves, come and talk to us, we'll help you find those opportunities. It's all about driving up top-line business growth and driving up that bottom line. 3D printing is a tool for driving out inefficiency, driving out waste. The guys who really need to understand this are your Kaizen guys, your Six Sigma guys, the guys on the shop floor. That's where you'll see the biggest benefit from the technology. If anyone wants to see us, we're just over there in the corner, so please come and have a chat. That's my 7 minutes up, so I will hand on to the next person. Thank you.